On January 16, 1945, at a dusty airfield in Suqin, China, Japanese soldiers surrounded an American fighter that had just landed in their territory. The pilot, First Lieutenant Oliver Strawbridge of the 31st Fighter Group, was captured immediately. But it wasn't the pilot that would change everything. It was his aircraft, a P-51C Mustang, tail number 4414037, nicknamed Evalina, sat intact on Japanese-controlled ground. For the Imperial Japanese Army Air Force, this was an intelligence goldmine, one that would reveal a truth too devastating to accept. The war was already lost, not in the skies over Tokyo or the jungles of Okinawa, but in the factories, laboratories, and assembly lines of an industrial base Japan could never match. Since late 1943, Japanese pilots had been dying in increasing numbers against this new American fighter. Every encounter told the same story. The Mustang was faster, better armed, more durable, and seemingly unstoppable. Evaluating it became a top priority, not to copy it, but in the desperate hope that a tactically significant weakness could be discovered to even the odds. The Japanese understood the value of capturing enemy aircraft. The Americans had done exactly this in 1942 after recovering an intact A6M20 from Akuten Island. That single zero had revealed its fatal flaws: light construction, no self-sealing fuel tanks, minimal armor, allowing American pilots to develop the thatch weave and shatter Japanese air superiority in months. Now, the tables had turned. The capture, a wounded Mustang, and a fateful landing. Strawbridge's mission that day had been routine: escort B-24 liberators on a strike against Japanese supply lines in central China. But during the egress, his Mustang took ground fire. With a damaged radiator and oil pressure dropping, he knew he couldn't make it back to his base at Chengdu. Rather than bail out over hostile territory, he chose to land at Suqin, a former Chinese pilot. Airfield now under Japanese control. Miraculously, Evalina touched down in one piece. The Japanese, stunned by the arrival of an intact American fighter, secured the aircraft and pilot within minutes. The Mustang bore the scars of combat: bullet holes in the wings, a dented cowling, and the open red dragon mouth painted on the nose, a common American nose art symbolizing ferocity. Along the fuselage, 12 red victory dots marked Japanese aircraft shot down by Strawbridge and his squadron mates. Each dot represented a pilot who hadn't come home. Within days, Japanese mechanics repaired the damage. Whatever combat wounds Evalina had suffered were patched with remarkable speed. The American star and bar insignia were hastily overpainted with Hinamaru, the red sun of Japan, but the rest of the aircraft was left untouched. The sleek silver finish, the dragon mouth, the kill markings, all remained, a silent testament to the pilot who had flown her into enemy hands. The mission to fly Evalina back to Japan was given to Captain Yasuhiko Kuroe, a 30-victory ace and one of Japan's most experienced fighter pilots. Kuroe, who had flown zeros over Burma and China since 1942, was chosen not just for his skill, but for his analytical mind. He would be the first Japanese pilot to truly understand what they were facing. The revelation, a machine unlike any other. Kuroe climbed into the cockpit at the Suqin airfield on a cold January morning. The moment he started the engine, he knew something was profoundly different. The Packard-built Rolls-Royce Merlin V1650-3 roared to life with a smoothness he had never experienced in any Japanese aircraft. No rough idle, no hesitation, no vibration, just pure, controlled power. Japanese engines, even new ones, suffered from uneven power delivery, excessive vibration, and constant oil leaks due to lower quality bearings, inconsistent metallurgy, and wartime production shortcuts. But the Merlin felt like a single, perfectly balanced machine. And then Kuroe noticed something that genuinely shocked him. No oil leaks. In Japanese aviation, oil leaks were accepted as normal, a constant fire hazard and maintenance nightmare that reduced operational readiness. But this American engine was dry, sealed, perfect. To Kuroe, who had spent years wrestling with temperamental Sake and Homare engines, this small detail spoke volumes about American manufacturing tolerances, gasket quality, and quality control, standards Japan simply did not possess. As Kuroe flew Evalina back to Japan, he began systematically testing her capabilities. The controls were smooth and responsive, with none of the stickiness or slop common in Japanese fighters. He tried a high-speed dive. Japanese aircraft often became unstable or heavy in dives, limiting their tactical utility, but the P-51 dived like it was designed for it. Smooth, stable, and terrifyingly fast, faster than anything Kuroe had ever flown. When he landed at the Army Air Inspection Center in Fusa, near Tokyo, a crowd was waiting. Engineers, test pilots, intelligence officers, and senior commanders. Everyone wanted to see the legendary American fighter that had been slaughtering their pilots. As Kuroe climbed out, the first question everyone asked was the same. How does it fly? His answer was simple and devastating. Better than anything we have. The pilot's testimony, beyond flight performance. Kuroe would later recall his first impressions in meticulous detail. I was astonished with its performance, he wrote in a post-war memoir. Turn characteristics were splendid, almost the same as the Ki-84 in a horizontal turn. This was high praise. The Nakajima Ki-84 Frank was Japan's best operational fighter in early 1945. Fast, agile, and well-armed. But Kuroe's assessment went far beyond basic flight dynamics. He noted the excellent radio transmitter, a revelation in itself. Japanese aircraft radios were notoriously unreliable, so much so that many pilots simply didn't use them. The Mustang's clear, consistent communication meant American formations could coordinate complex tactics like the Thatch Weave, call out enemy positions, and receive real-time intelligence updates, granting a massive tactical advantage. Even more astonishing was the directional radio beacon, a device that could guide a pilot home in bad weather when lost or when wounded. Many Japanese pilots died not from combat, Kuroe observed, but from getting lost and running out of fuel. The inclusion of robust navigation and communication systems revealed an American design philosophy that valued the pilot's life and safe return. In the U.S. system, an aircraft was a repeatable manufactured asset. A trained pilot was an irreplaceable investment. Kuroe compared Evalina to another captured aircraft at Fusa, a German FW-190A acquired through Axis cooperation. Its dash speed was inferior to that of our imported FW-190A, he noted. The German fighter had a slight edge in straight-line speed, but diving speed and stability during the dive were excellent. This was crucial. Modern air combat wasn't about top speed. It was about energy management, diving on an enemy, making a firing pass, and escaping before they could respond. The Mustang excelled at this. Then came the fuel consumption tests, and the results were chilling. After fuel consumption tests, we estimated it would be able to fly over the Japanese homeland from Iwo Jima. Kuroe added a haunting postscript. Sometime later, this came true. The veteran's perspective. A pilot who had fought the Mustang. Another ace, Major Yohei Hinoi, was ordered to master the P-51 and demonstrate it to other Japanese pilots. Hinoi had a unique perspective. In November 1943, he had shot down a Mustang over Burma. Days later, a Mustang shot him down, costing him his left leg. Now flying with an artificial limb, he approached Evalina with both professional curiosity and personal history. I could see the superiority of its equipment, Hinoi recalled, and its shiny fuselage with the open red mouth of a dragon. I saw several red dots on the side of the cockpit, probably recording Japanese aircraft the pilot had shot down. Getting in, he was struck by the roomy cockpit. Japanese fighter cockpits, especially the Zeros, were cramped, minimalist, and unforgiving. The Mustang's spaciousness was immediately noticeable. I did not have any trouble with my artificial leg on the rudder pedal, he noted, a small but telling detail about American ergonomics and pilot-centered design. Hinoi identified 3 revolutionary features. Bullet pick. Glass with superior transparency compared to Japan's thin, distorted panes. A thick steel armor plate behind the seat, something he had never seen in a fighter before. An automatic radiator shutter and reliable oxygen system, features absent in most Japanese aircraft. Japanese pilots flew with minimal protection. A single .50 caliber hit could kill a veteran, who would then be replaced by an inexperienced cadet with 50 flight hours versus 400 plus for Americans. The Mustang's armor and self-sealing tanks meant pilots could survive hits and return to fight again, conserving Japan's most critical deficit, experienced aviators. Hinoi's conclusion was devastating. Overall, it was better equipped than any Japanese airplane I had ever seen. The engineers report, a mirror to industrial collapse. While pilots tested Evalina in the air, engineers on the ground conducted a forensic examination. They focused intensely on the Packard Merlin engine, measuring tolerances, analyzing metalure, and reverse engineering components. What they found was disturbing. Every part, crankshaft, pistons, valves, bearings, showed manufacturing precision that exceeded anything in Japanese production. The Americans had mastered the mass production of complex, high-performance engines, achieving consistency across thousands of units, a standard Japan could only dream of. But it wasn't just quality. Intelligence reports confirmed what the engineers suspected. Packard was mass-producing these engines at a rate of 1,000 per month. Total Merlin production would exceed 55,000 units by war's end. Japanese engineers did the grim arithmetic. Japan's total aircraft engine production for the entire war, all types combined, was approximately 60,000 units. American production of one engine type, approximately 55,000 units. The scale was horrifying. For every Merlin Japan produced, America was delivering nearly one. Even more chilling, while Japan's production quality was visibly declining in 1945. Using inferior alloys, accepting wider tolerances, skipping inspections, the Merlin in Evalina showed no compromise in finish or strength. It represented a stable, mature industrial base focused on performance and reliability. The P-51 itself was a resource statement. It required 6,000 pounds of aluminum and high-tensile steel, advanced electronics for radios and navigation, precision-machined components from an unbombed industrial heartland. Any one of these would strain Japan's war economy. The Mustang had all of them, and was being mass-produced. North American Aviation built P-51s at rates that seemed impossible. Peak production, 500-plus aircraft per month by late 1944. Total P-51 production, 15,600-plus units. Japan's entire fighter production across all types struggled to reach 400 per month and was falling as American bombing intensified. The disparity wasn't just numerical, it was philosophical. American factories employed thousands of women, minorities, and untrained workers, shattering the Nazi-Japanese ideological belief that only a pure warrior society could build advanced weapons. The tactical reality, no counter to overwhelming superiority. Evalina was transferred to a Kino flying division for mock combat against Japan's best fighters, the Ki-43 Oscar, Ki-61 Tony, and Ki-84 Frank. The results were sobering. After extensive testing, Kuroe made a statement that revealed the true depth of the problem. "I had such confidence with this P-51 that I feared no Japanese fighters." A 30-victory Japanese ace was saying that in an American fighter, he could defeat any Japanese aircraft. The Mustang's high-energy tactics, high-speed dives, rapid zoom climbs were impossible for lighter, more fragile Japanese fighters to counter, even when flown by skilled pilots. In mid-April 1945, Kuroe was given command of a flying circus of captured Allied aircraft. They toured Japanese fighter units, teaching pilots not how to win, but how to survive against superior enemy planes. First Lieutenant Masatogu Sumita recalled learning how to break out of the P-51's pursuit axis when chased, a desperate tactic of evasion, not engagement. This flying circus became Japan's last-ditch attempt to mitigate industrial disparity. It tacitly acknowledged that air superiority was lost. The primary mission was now merely to delay defeat. Japanese strategy shifted entirely from offense to minimal defense. The suppressed truth, when facts contradict ideology. Japanese engineers compiled their findings into a comprehensive technical report. Evalina, they concluded, represented industrial capabilities Japan could never match. The report was forwarded up the chain of command. Like similar reports from German engineers examining American equipment, it was quietly filed awe. The detailed analysis, particularly the undeniable production statistics comparing Merlin output to Japan's total engine production, was deemed defeatist by the Imperial High Command. In Japan's military culture of 1945, admitting American superiority was politically impossible. Officers who voiced pessimistic assessments were labeled traitors. Engineers who presented the data, including senior officials at the Army Air Inspection Center, faced immediate demotion or reassignment to meaningless posts. The system chose to eliminate the messenger rather than confront the message. The truth about Evalina remained confined to technical reports that few read and fewer acted upon. The final irony, a generator that silenced a ghost. Evalina served Japanese testing purposes for several months. But eventually, the electrical generator burned out. Japanese engineers concluded they couldn't repair it with available materials. They couldn't manufacture a replacement, so Evalina was grounded. The American ghost that had revealed so many uncomfortable truths was silenced by something as simple as a failed generator. 2 P-51Ds were reportedly captured in mainland Japan in 1945, but their fate is unknown. By then, it didn't matter. The fuel consumption calculations had been prophetic. Starting in late 1944, P-51s began escorting B-29 superfortresses from Iwo Jima to Japan. Japanese fighters rose to defend their homeland and were overwhelmed. When the war ended in August 1945, the final numbers told the story with mathematical precision. U.S. military aircraft production, 1940 to 1945, 300,000 plus. Japanese production, approximately 70,000. Ratio more than 4 to 1. America built more P-51s, 15,600, than Japan built of its two most numerous fighters combined. And while late-war Japanese aircraft showed increasing evidence of shortcuts, lower-grade materials, and quality control failures, American production maintained or improved its standards. The legacy, a mirror to two wars. The story of Evalina parallels the captured Zero incident of 1942, but with a tragic reversal. In 1942, the Americans captured a Zero, studied it, identified its weaknesses, and adapted their tactics. They developed the THAC weave, exploited the Zero's lack of armor and self-sealing tanks, and eliminated Japanese air superiority in months. In 1945, the Japanese captured Evalina, studied it thoroughly, and identified not weaknesses, but overwhelming strengths they couldn't counter. They tried to adapt, teaching survival techniques, but no tactical innovation could overcome being outproduced 4 to 1. The contrast revealed a fundamental difference in organizational philosophy. American military intelligence used facts to ruthlessly self-correct and improve. The Japanese system could only use facts to confirm ideological despair, but never to change strategy or production. Both Nazi Germany and Imperial Japan had built their war efforts on the belief that spirit could defeat material. To admit that American equipment was fundamentally superior wasn't just a military assessment. It was a challenge to the entire ideological foundation of the war. But mathematics doesn't care about ideology. Industrial capacity is measurable. The United States had vast natural resources, a population of 130 million, and the world's largest industrial base, all focused on war production without fear of invasion. The final truth. On January 16, 1945, when First Lieutenant Oliver Strawbridge landed his damaged P-51C at Suchin Airfield, he handed the Japanese military a complete picture of their defeat. Evalina sat in Japanese hangars for only a few months before her generator failed. But in that brief time, she revealed truths that were impossible to deny. The Japanese engineers who examined her in early 1945 saw their destiny clearly. They understood that the war was lost. They reported it honestly, and they couldn't change a single thing about it. That day in January 1945 was the day that truth became undeniable. The American ghost had spoken, and its message was written not in propaganda, but in aluminum, steel, and the unstoppable mathematics of modern industrial warfare.